Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into firmware and update debt, managing software lifecycles in networked buildings, why it matters, where projects usually go wrong, and what decision makers need to understand before problems show up in production. Joining me today is Michael Harrington, and together we'll break this down from a practical, real-world perspective.
Cold open. Imagine this. It's Tuesday morning. Tenants are streaming into a high-rise. The digital directory and access control platform both prompt an unexpected reboot after a background firmware push. At the same time, a delayed security patch for a climate control controller fails to install, sending elevators into degraded mode. Tenants can't badge in, deliveries are delayed, and the property team is fielding calls. This is an operational and business risk, not an IT curiosity.
From an operational standpoint, that scenario is the exact collision we try to prevent. What breaks if this goes down? Tenants feel this immediately. One untested update can cascade through systems you didn't even know were interdependent.
Today, we unpack that collision. We'll cover what update debt looks like in the field, the trade-offs teams have to manage between uptime and security, and practical coordination tactics, staging environments, maintenance windows, rollback plans, and simple inventory hygiene. By the end, you'll have a checklist you can use tomorrow. What life cycle risk looks like? Michael, start by describing how update debt accumulates in a typical commercial building portfolio.
Sure. It starts small. A controller installed during fit-out gets left on a stable firmware that matches the integrator's test suite. Over time, new features and security fixes come out, but they're applied unevenly. Some devices get updated, some don't. That version drift creates single points of failure, devices that are unsupported or incompatible with newer management platforms. Inventory rot sets in because teams don't maintain a lived list of versions and owners.
Inventory rot is a phrase I hear a lot. How do teams detect it early without an army of spreadsheets and endless site walks?
Start with ownership. Even a lightweight inventory that records device type, installed firmware, last update date, and who owns it reduces surprise. Add simple scans during maintenance and tie them to a quarterly review. You don't need to track every patch level forever. You need to know where the high-impact pieces are, access control servers, elevator controllers, core BMS gateways, and treat those as priorities.
So the risk is both technical and organizational, unsupported firmware and unclear ownership. That leads us into segment 2, trade-offs and governance. Michael, how should teams prioritize updates when they can't do everything at once?
You need a risk-based prioritization framework. Ask 3 questions for each update. What's the impact if it's missed? What's the likelihood of exploitation or failure? And what's the cost or disruption to apply it? High-impact security fixes on control servers are top priority. Low-risk feature updates can be batched into maintenance windows. That lets you balance security and uptime without creating constant tenant disruption.
Maintenance windows are part of this, but they're a double-edged sword. Tenants hate surprises. How do you set and communicate windows that are both effective and minimally disruptive?
Consistency and expectation setting. Establish cadence, for example, monthly non-critical updates during late-night windows and immediate windows for critical security patches. Give tenants advance notice, offer a point of contact during the window, and have rollback plans. If tenants know when to expect maintenance and that you have a tested rollback, the tolerance for short disruptions increases.
You mentioned rollback plans. That leads into practical staging and testing. What does a reasonable staging approach look like for property teams with limited lab resources?
A minimal viable staging approach is twofold. First, maintain a small on-site sandbox, a single rack or cabinet with representative devices and the same network segmentation as production. Run updates there first. Second, use phased rollouts. Update a low-risk subset of units in one building, monitor for 48 to 72 hours, then expand. For critical systems, vendor change control and test scripts are essential, so you can recreate failures and validate rollbacks.
Segment 3, coordination in practice. Michael, how do you align vendors, IT, and facilities around shared runbooks without creating bureaucratic slowdowns?
Make roles explicit and keep runbooks concise. Have an owner for each update event who coordinates. That could be facilities for physical access systems, IT for network changes, and the vendor for device-level firmware. Define decision gates. Who approves a rollout? Who signs off after staging? And who triggers rollback? Keep communication templates ready. Email, SMS, and on-site radio scripts, so during an event, everyone uses the same language.
What about contracts and vendor commitments? Can that avoid last-minute surprises?
Yes, build lifecycle expectations into vendor agreements, guaranteed notification windows for breaking changes, clear support lifecycles, and escalation paths. Don't ask vendors to do everything for free, but do ensure they supply firmware release notes, known incompatibilities, and rollback images. These contract-level items save weeks of friction when an urgent update arrives.
Expert insight and examples. 2 short case studies. Michael, tell us about a successful staged rollout you led and one outage you helped avoid.
Successful rollout first. We had a portfolio of 3 buildings with a common access control headend. We created a sandbox, staged the vendor firmware there, and performed a phased rollout over 6 weeks during nightly maintenance windows. We tracked metrics for login latency and badge acceptance and had a one-click rollback prepared. The staged approach caught a regression in a secondary module before it reached tenants, and the overall upgrade completed with minimal impact. The avoided outage. A vendor issued a critical patch that required a reboot of a gateway during business hours. Because we had an owned by inventory and an approval gate, we identified a conflicting scheduled building event and postponed the update 24 hours to perform it in a controlled window. That 24-hour delay prevented mass badge failures during the event.
Both stories highlight preparation and owning the process. Let's wrap up with key takeaways, a short checklist listeners can use immediately.
Checklist. 1. Inventory hygiene. Capture device type, firmware, owner, last update. Keep it current. 2. Risk-based prioritization. Score updates by impact, likelihood, and disruption. 3. Staging and phased rollouts. Use a sandbox and phased production updates. 4. Maintenance windows and tenant communication. Set predictable cadence and templates. 5. Rollback plans and test scripts. Validate rollback before you need it. 6. Contractual lifecycle clauses. Require vendor notifications, release notes, and support lifecycles. 7. Budgeting. Plan OpEx for recurring lifecycle work. Don't treat it as an afterthought.
That's actionable. If you take nothing else from this episode, start with ownership. Who is responsible for firmware in your buildings today, and what's your next maintenance window? Those 2 answers unlock the rest.
For templates, a sample inventory spreadsheet, and our maintenance communication templates, visit our show page. You'll find episode notes and resources to help you implement the checklist we discussed. Visit site. That wraps up today's episode of Built, Wired, and Secured. We covered managing firmware and update debt across networked building systems, and hopefully gave you a clearer way to think about governance, staging, and coordination, so these decisions don't turn into tenant-facing outages. Thanks for spending time with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.